let's get started, I guess. So hi, I'm Joe Vieira. I currently work at Ovia Health as the senior software architect. Ovia Health is a women's health tech company. So we make fertility, pregnancy, and parenting apps. And my team is responsible for the backend, which is written in PHP. That's why I'm here. We use a pretty standard kind of LAMP stack in AWS. I've previously worked at Monotype at myfonts.com, which if you guys are UX people and into typography, I ran the team at myfonts for a long time. I also teach Python, data science, and R at General Assembly. So if you guys are into learning other things, General Assembly is super cool, and their classes are pretty accessible and reasonably priced too, which is super nice. Another person running across.
Time out for a sec.
Okay. Is everything okay?
Not working.
Wait, what's not working now?
What's that? Kristen was in here. Kristen helped me get it connected.
Yeah.
And she didn't know to turn on the recording because we didn't tell her.
Yeah, he did.
Good? All right. I'm sure you won't edit this out. Like put flashing on the screen. This is Bobby talking.
Cool, that was exciting. All right, everything's good. We're just going to keep going forward here. So we're going to talk about tests today. So in my current role, and actually in my previous role, I inherited a pretty large monolith that didn't have a lot of test coverage, or no test coverage at all. No tests, in fact, at all, which is a tough place to walk into because you don't have any confidence in the code that you're changing. You don't have any confidence in the code that exists, even in some ways. So I want to spend a little bit of time trying to kind of build a common definition of what unit testing is. I think it's pretty well known what a unit test is, but I think there's a lot of misconceptions also. So this is going to be kind of interactive. There's a lot of people towards the back of the room, but I'm still going to call on people because I teach courses at General Assembly, so I call on people. So what do you guys think unit testing is? Volunteers first. Otherwise, I randomly choose. Yes? OK. Yep. Oh, actually, hold on. I want to. You're right. Yes. But also, I want to kind of canvass the room. Who has experience writing unit tests in their production code? Matt Dwayne, you don't count because I make you write them. All right. So that was 4 people in this whole room. How many of you are developers? That scares me. So one of my good friends, I was just texting about this talk that I was doing at this conference today. His response to me was, PHP developers don't write tests. They test in production. And I was like, fuck. He's right. So you guys kind of proved that, right? And so I'm glad you're here. Why don't you write tests? Someone who doesn't write tests and is a developer.
I do write tests.
Yeah, that's fair. Well, what are reasons that people don't write tests?
One of the excuses I have given is I don't have enough time to write the test at the same time as I'm writing the code.
OK. There was someone else. Yeah, Barrett. And that is what we're here to talk about. Yes. So, right, common misconception that PHP developers don't write tests, because some do, and some do it really effectively. But a lot of times, we have inherited apps that just have a really hard time supporting tests. That's not your fault, unless you're the one who wrote the legacy code. But it is still also your stewardship that has to drive that forward and make it better, right? So I ride bicycles a lot. They're a little bigger than this one. But the previous talk on testing that Chris did before lunch, I'm not sure if you guys were there, but he talked about TDD, right? So TDD is awesome. And he talked about defining an architecture that really enables TDD and enables testing. Tests in a green field, like he was talking about, are like this kid with training wheels. It works really well, right? This bike is low. There's not a lot of complicated stuff going on. This kid hasn't made a bunch of mistakes. He's learning how to ride a bike the right way the first time. But if you're an adult and you put training wheels on your bike, you already have some expectations. Those training wheels aren't going to work very well, right? This is just a weird bike analogy. There's going to be a couple of them. Just bear with them, all right? I'm sorry. So what is a unit test? We kind of covered this, right? It's testing a single amount of code. It's low level, and it should be significantly faster than other kinds of tests. So did someone just? Oh, sorry. So it should be faster than manual testing, obviously. It should be faster than your integration testing, because it should only test one thing at a time. The reason why it's faster is because it only tests one thing at a time, and because it does it in isolation. These are whole things of what's important in tests. They should be fully automated. You shouldn't have to do a bunch of stuff in order for your tests to run. They should have full control over all the pieces that are running. So your test should be able to set up its entire environment automatically and get it back to a state at the end of it where it can run again. It can be run in any order. So your test 5 shouldn't rely on test 1 running first. You should be able to run test 5 by itself. And in fact, that's a really valuable thing when you're doing development work, right? You want to just run that one test on the thing you're working on. Eventually, when you're done your feature change, you're going to want to run all of your test suite again. But during that time when you're actually typing code, you only want to run the couple tests that matter. It runs in memory. It consistently returns the same results. So having things like random number generators or things that are tightly coupled to dates is a difficult thing to have in tests, right? You shouldn't have a random number generator that's running in your test unless you're testing the assertion that it's just giving you a random number, which is also difficult. They should run fast. They should be able to test a single logical component. They should be really, really readable. You should be able to understand what's going on in a test, hopefully, even more than you can understand what's going on in your production code. And they should be really maintainable. That kind of plays into readable. How many of you think that unit tests stop bugs or stop regressions? Good. I mean, I kind of gave it away, right? They don't stop bugs, and they don't stop regressions. They can definitely help you along the way, right? If you understand the context and the bounds in which your system is supposed to operate, you can definitely put some gutters on that bowling alley up to stop the ball from going to the next alley. But like, you can only write tests about things you know about, and only really stop regressions that you have a solid context on. If there's edge cases that you don't fully understand as a developer, that QA doesn't fully understand, then it's not going to just stop them out of the blue, right? It's also really important to have a good code review process when you're writing tests, right? Because another developer might see an aspect of that test that you're missing, or rather an aspect of your code that you're not covering with your tests. So just trying to get some bounds around what tests are, what they're good for, and what they're bad for. What they're really good for is making refactoring easier, because if you have the context of your system and you know exactly what it should be doing and what it shouldn't be doing, then your test coverage makes refactoring that code easier. It helps you compartmentalize your software. It makes you really think about your dependencies and your system interactions. And it also ensures that any APIs you have meet their contracts. So that's kind of just a high level so that we have a shared understanding of what I'm going to talk about when I say unit tests. I'm not going to dive into integration tests, even though they are super important and also really helpful when you're dealing with legacy systems. But I do really want to think about ways that we can decouple some of the dependencies and dive into actually unit tests in legacy systems. Now we're going to move into the definition of legacy. What do you guys think legacy software is? I mean, if you're gonna put back the okay, so everyone's read everyone's read Michael Feather's book, I assume. Good, but you don't have tests still, but you read the book. All right, other definitions of legacy software. No, it's code the person who had your job before you wrote. Your code can't be legacy. It's yours. What's that? Yeah. It's good. We have some solid heckling. I like it. Yes? Yeah, so you can very solidly say and make the case that legacy code is anything that is sort of considered deprecated in your current system. We currently still run on PHP 5.6. I would call everything we have legacy and deprecated. So our app is currently in it's pretty much all legacy code state. Now, that said, I don't, this definition, right, is kind of narrow because we just described a bunch of other definitions of legacy. There's legacy code that has tests on it because it's running outside your framework, it's running an old version. It's not an architecture that's preferred currently. Some common issues in legacy code. One, it's probably poorly designed. That's why we're having this conversation, right? So it probably has hidden dependencies where you're instantiating other classes deep inside this class that shouldn't be doing that. It probably is accessing global variables directly. Probably is doing direct I/O. And the classes are probably way too big. Matt, I'm going to pick on you because you work at Ovia. How big do you think the largest class we have is? So when you're dealing in this situation, right, you have, I feel like 10,000 is exaggeration, Matt, but I like it. I like where you're going with it. So let's say, I mean, the comment I had was 2,000. I feel like 2,000 is already too much. So when you have a class that's that large, like, is that really one responsibility? Like, there's no way it is, right? Like, unless your responsibility is like, I don't know, like making all the planets move and calculating the gravity of them all correctly. And even then, you should probably break it out into separate classes. It's like a really large definition of responsibility, right? Yeah. So those four things are really what I wanted to cover because these are the issues you see in every legacy app, right? They all do this. It's all terrible. We have to move on from it. Hidden dependencies. So we have this like nice little, this is all fake code. This is not Ovia code or any code from any of my employers. I just typed this. There's probably not even, it's not probably even going to work because I typed it in like Google Present. So we're just instantiating a new copy of this new database class in the middle of this method that's in the middle of this function that, or it's in the middle of this class that probably shouldn't be doing that, right? And then it's running a query. And then it's doing some other stuff, and then it's going to return a result. Right? Like, that's just not a good situation. You can't test this because you have a dependency in database connection there. Globals. You're deep inside a class, and you see that it's reaching out, and it's using web server variables. That's not good for lots of reasons. Firstly, like, you're probably using something that's not sanitized. So, do you have a SQL injection there? Maybe. On the other hand, like you also can't test that because that's relying on context from a web server. That's not going to be in your CLI when you run your unit tests. So how do you do this? Now you're going to start like manipulating the request object in your tests, and your test is just going to not make any sense really. It's just a terrible practice. Don't have tons of that sitting inside your classes, unless your class is dealing with brokering requests. In which case, that is the responsibility of that class, and that's fine. These guys in the middle of your classes, how do you test this? Right? You have a reliance on an actual file system now. You're going to just start writing stuff onto your Jenkins server. Your DevOps person's going to be like, hey, Joe, you filled the Jenkins server up with a bunch of test files. What's that all about? You also have a reliance on the file structure, like the actual structure of the file system. Are your tests going to work when a developer uses Windows and you're accessing like /temp? No, probably not. You have these guys that do everything wrong, right? This is just compounding of all of the stuff, and you're basically just not going to have a chance. Let's just like give up, go home, call it a day. Hopefully it's a Friday and you can have a beer, right? This is legacy code, right? Like this is what we deal with every day when we have a legacy app. Now we have a common understanding of what legacy is. It's a ripe mess and it's a pile of shit. Guys, also, I'm sorry, I swear. It's not to be offensive. We have this mammoth class that we talked about, 10,000 lines. Lots of responsibilities, lots of lines. How do we move forward from this in a safe way? How do we move forward from this in a way that helps actually increase the safety of the organization rather than just doubling down on the problems that we have, right? If we were to add a feature into this, the easy path is to add another if statement, to add another method into it, move on with our lives. We didn't increase the code coverage. We didn't increase the robustness of the app. And we're just compounding on technical debt, right? So when we're approaching this, we have to think about ways to make that a little bit better. Now we're going to move into the ways to do that. There's a lot of them. I'm going to cover some, specifically for those 4 cases. But again, for the effectively dealing with legacy code examples, there's 5 steps to this, right? And it's identify where you need to make change. It's find the place you can insert a test, break the dependencies around that, write the tests for it, and then make your feature change. So you're in this dilemma of you need to make changes to get your tests in place, but you shouldn't change your features until you get your tests in place. So you have to make 2 different changes, and you should do them independently, right? Because you want to test your system as it exists currently, and then test your system after you make the changes. If you do them at the same time, how do you know that your system worked right in the first place, or that your system works right in the second place? It's kind of an unfair dilemma sometimes when you're dealing with these legacy systems, but that's why this guy on the bike has armor and a helmet and a shield. He's taking lots of different strategies to avoid these unsafe situations. I kind of wish he had more armor on, like a bubble or something, but like Adobe stock images only have so many pictures of people on bikes with armor, and this is the only one I could find. It's pretty good, though, right? Like, we start with the training wheels, and then we get the kid with armor. So one of the ways we can start doing this, right, in our hidden dependency case is adding dependency injection. Does everybody understand what dependency injection is? Does everyone understand why it's important in unit testing? What is mocking? Yes. So the reason why dependency injection is so important is because you need to have test doubles so that you can break the coupling between other systems, right? So if we have a database, we don't want our system under test to actually access the database, because even if we set the database up in memory, it relies on the schema of the database being correct. It relies on having the drivers for that memory database. Like, we built an integration test, which is great, but it's not a unit test, right? In order to have a unit test, we need to have a hard line of you have full control over this, and it won't cross that boundary ever, right? And to do that, we use dependency injection. We want to make a test double. We want to push that in place, and then we want to be able to control that entirely. We also want to be able to control the return results from it so that we can force the system under test into specific branches of code. So we can do dependency injection in PHP in a couple of ways. It's not as elegant as in some languages, but you can set, let's go to that slide. We can pass in database there, and in this case, I'm passing it in as null. So we have a default here. So if it's null, then I'm instantiating it. And this isn't great, but it stops us from having to change our signature across our entire legacy app. And also, you don't know who's going to, like, how many places that's used. In a 10,000-line file, like, you're changing a lot of spots. You have to instantiate tons of copies of this and all the client code. Sometimes that can be maybe not risky, but inconvenient. It kind of changes the scope of your change. But when you can, for the cases of testing, inject something, but in the cases of production, do the exact same branch, then you've limited your risk a little bit, right? So in legacy systems, adding testing while limiting your risk is kind of your game plan, right? Because you're not going to have perfect compartmentalized code. You're not going to have everything perfect. You just want to limit your risk while adding some more safety. So we can do that here in this way. I'm pointing down here. I should point up there for you guys. Sorry. This screen is so convenient and beautiful. The other way to do it is with superseding setters. So if we really need to have these defaults set up by something, we can make these other methods that just happen to conveniently overwrite that later in our tests. That's kind of ugly, right? Like now you have these public methods that can overwrite stuff that the constructor is setting up. Not really ideal, but again, back to the kid in armor, like do what you got to do, right? Like it's not going to be a beautiful system, but it's going to build some more safety around it. You know, you should probably like leave some documentation there that says like, don't use this, like please, I really mean it. Name it something inconvenient. Don't just call it set database connection, unless you really want to be able to just do that anywhere, right? We can add encapsulation for our globals and for our lower level calls and libraries. So if we set up wrappers or encapsulate all of those kind of access to globals, so we make a specific class that's responsible for doing all the access to the request superglobal, or a class that's responsible for doing all of the file I/O, right? Now you have one crunch point there that wraps all of that important low-level stuff, and you can, at that point, you can test that using other tools, right? Now you want to be able to test that, of course, right? But because it's only happening in one spot, you only have to set up those complicated and a little more fragile tests on that class, not on every class that uses fwrite, not on every class that tries to access request. So with direct I/O, you can use encapsulation, and then in the place where you're encapsulating, you can emulate a file system using something like VFS stream, which is really convenient for emulating a file system, but is also kind of a pain to set up in every one of your tests because it requires like setting up a handler and then setting up like where all the roots are and doing like 15 different steps, which is like arcane magic. Put it in one spot, have your encapsulating class, have that test, have everything else just use your encapsulating test, and then you're just good. All right, here, just this case. This is just wrapping it, right? Open file, calls fopen. That doesn't really help you in a lot of ways, and in a lot of ways, it's a hidden dependency, right? But if that's the only place in your entire app that you ever call fopen, you've actually made your app a lot safer, because you can test this reasonably, and then you can use it everywhere. Let's see, what else did I write about this? That's about it. Has anyone used VFS stream? It's a pretty cool library. I totally recommend it. I also have like all of the random things I splattered throughout this. I have resources linked at the end. I highly recommend when you're testing direct I/O, VFS stream is the way to go. Mammoth classes are really, really hard to deal with when you're starting to write tests. You have really that boils down to one option, right? It's just reduce complexity. So you want to find related methods and properties and pull them out in another class. Strategies for doing that, I mean, really, one, when you start doing this and say, like, I'm going to write tests for this class, you are embarking down a road, and it's going to be slippery and hairy, and it's not going to be fun. But at the end of the day, you will have probably made something that is much better than what you started with, so you should take some pride in that. So do it at your own risk, but do it. So strategies for really thinking about how to decompose these things, right? You actually want to, in these cases, spend some time and make a UML diagram. You want to map it out because you need to understand the relationships between all of those methods, and all of the properties that they're doing bad things to, probably, and all of the dependencies they have hidden in them. And the only way you can do that is you have to be organized. You can't just like open your IDE and like just start doing it. You have to spend some time. You have to really understand what's going on. You have to draw it out. And then you have to start saying, OK, where are the logical places I can break this into separate classes? The Effectively Dealing with Legacy Code book has tons of great like strategies for dealing with that. I don't want to dive into too much, but basically it's make a UML, find the things that touch each other, move them to separate classes. There's other strategies to doing it too. If you want to really start thinking about better patterns for that code, you probably can't do it in one stint. So that the right thing to usually do is to break it out into smaller classes, get some tests around those, and then start thinking about better patterns to use inside that. Like, is this really an orchestration of a couple different events? Do I need to use, like, or is it a couple of different actual objects? Do I need to think about using a builder pattern or something that helps me, maybe like a decorator pattern, right? Because like maybe there's 15 different ways this object can be created. And you just need to think about different ways you can decorate it. So if you can start with a base class, add some decorators into it, maybe that's a reasonable approach. But thinking about that from like taking a step back, drawing it out, and planning it well is going to be your strategy there. This is the other one. You can sprout new classes or new methods. So this is like literally giving up. This is like, this class is a hot mess, and I have to add a feature, so I'm going to do it in a new place. And then I will just use it in my hot mess. I actually did this the other day. We have, so in our apps, right, like you're a woman who's tracking her pregnancy, and things happen maybe, like you have to log data that's maybe like an emergency. So we push an alert to them at that point. And we say like, hey, you should call your doctor. But in order to do that, we need to know the person's doctor, right? Like, we need to know what their phone number is. But our alert system is really based on like templated strings. So we need to take this templated string and then look up the person's user, like the user's phone number, or the user's doctor's phone number from that. And the system we had in place didn't really do that well. And it also was like a 500-line method that was just like running through tons of like if statements of just like, if this, do this thing, if this, do this other thing. And I just really didn't want to add 5 more if statements into it because, one, I knew I couldn't test that method. I didn't really understand everything that method was doing or why it was doing it. So I made a brand new class, tested that class extensively, and then just threw it in there. So it's like, I know my class works. I don't trust the rest of it, but at least I'm leaving it alone and not potentially introducing a bug. I'm adding something that I know works. Nah, it's not really the best move. I kind of admitted defeat and was like, I have to release this feature this sprint, so let's figure out the best way to do this. Has anyone ever done something like that to get tests in place? Matt Dwayne again, thanks. Yeah, I know, right? So when you've done that, like, how have you felt after doing it? Did you feel good or dirty? You felt better?
Yeah, I threw away so much of it.
Yeah?
Yeah.
You just like threw away, like grabbed a bunch, encapsulated it all in something else, wrote tests around it?
Yep.
Yeah?
Bye-bye.
It's like a good feeling, right? You've just like crafted something a little bit better that you can leave behind. When someone sees that Git commit, they're going to be like, not an idiot. They might look at other ones and have other questions, but that one. So those are like the core strategies for dealing with those 4 kind of core problems. I want to spend a couple minutes also talking about metrics. So I am both an architect and an engineering manager, so I care about metrics because I want to see how my team's performing and ensure that we're doing a better job over time, because That's important as a manager. It's also important as an individual contributor engineer, right? Like, you want to know that the things you're doing have impact and they move the needle on quality. Test coverage metrics aren't really necessarily a measure of quality, but they might be a slight proxy for it, hopefully. If they're not a measure, if they're not a proxy of quality, then your tests are very bad, right? Does anybody know what this is? All right, back of the room. Don't read it, don't read it. Yeah. Yeah. So it sounds like you're just as bad off as us. Yeah. So a cyclomatic complexity is really just trying to measure. It's not the most perfectly defined metric, but it's trying to measure sort of the complexity of your code by checking how many paths are possible to be taken. So code that has a lot of if statements, code that has a lot of loops, switches, whatever control structures are in place there that can change the branching of it, they're going to increase the cyclomatic complexity. Why is this important? So the actual amount of branching your code takes is how many tests you need to cover it. So if your code has a cyclomatic complexity of 400, in order to test all of those branches, you need about 400 tests. And like that's rough because like some of those tests can be optimized out, right? But generally speaking, you need about as many tests as your code is complex. Keep your method simple, and you need fewer tests. Code coverage. I think this is obvious, right? It's how much of your code is exercised by your tests. There's a couple ways to kind of measure it: line, method, and class coverage. There's other ways too. Line coverage, how many lines are actually covered. Methods is how many methods are completely covered. Classes is how many classes are completely covered. I don't use method or class coverage because I don't expect line coverage to be 100%. Like in the cases of, where were we? Up here, in your test, that line will never get executed, right? So your best case scenario is having all the other ones. That's your best case scenario. So if I was using that, right, method and class coverage would never count that method. So it doesn't really help you, right? It's artificially low. Or if you have 100% test coverage, then that's great. Good job for you. So I use line coverage when we're doing this kind of stuff. It's helpful. Path coverage is, in an ideal world, what you really want to use. You want to understand how many of the paths your code has actually get covered by tests. PHP unit doesn't support this conveniently, so it doesn't matter. But in an ideal world, if Sebastian did a slightly better job with PHP unit, and he's pretty awesome, but we would have path coverage. Again, as a measure of the number of tests you need to cover every path, you can't measure it directly in PHP unit. You can just check your line coverage, which you should do when you're doing code reviews. And your team should be responsible for writing tests when they put up a PR. Good job, Matt Dwayne. I like having one of my employees here to banter at. Crap index. Does anybody know what this is? This is a real thing. This is not, I'm not making this up. OK, cool. So this stands for change, risk, anti-patterns. Yeah, I'm pretty sure they made that name just so it fit in the crap index. So you can actually just say, hey, that code's crappy. So this is a relationship between the complexity of code, the cyclomatic complexity, and the line coverage, basically, and actually the path coverage. So as the number of branches of code that aren't covered increases, the crap index increases exponentially, I think, actually. I don't have the formula written down. I don't quite remember off the top of my head. But on the positive side, the PHP unit code coverage engine does output the crap index for every method and class. And it is a very good metric to use, I think, personally. So if you just run code coverage and if you just run code coverage and like look at the HTML version of the output, or like look at it inside of a coverage browser, you can see the graph index, you can see the lines covered, what lines are covered, et cetera, which is super helpful, I think. So some tools. I said I would cover some of the tools that I kind of mentioned, and a couple other ones too. So PHP unit is, I think, the only unit testing framework I've used for PHP. Has anyone used anything else? Yeah. Codeception's a good framework, and I'm going to talk about one of their tools in a minute. If you've used aspect mock. OK. We can go to it now. So when you say using anonymous classes? Mm-hmm. Yep. Yeah. So even without an anonymous class, you can still do that, right? You can actually just extend it. You can write a class that just does that. Yeah, totally. And I agree with that. The approaches that you can take for test doubles are like limitless, right? These are just like some of the tools that are very helpful. PHP unit mocking can be pretty helpful. Aspect mock is cool because it lets you do runtime replacement of classes. So if you have a class that has a hidden dependency and for some reason you can't tease it out, aspect mock will basically change the autoloaders so that you can inject a mock in that even though you haven't passed a mock through. So it replaces the entire actual loaded library with this mock class. It's a very helpful tool when you're adding tests into legacy code. I cannot recommend it enough. It's one of the only reasons that at Ovia we can do good testing. PHP mock is kind of another autoloader namespace trick to mock out built-in functions. VFS stream is virtual file systems. It's super helpful, and it's very, very, I don't know, it's very well supported. PHP mess detector for getting some of these metrics, like cyclomatic complexity, and then like various other metrics too. But from this perspective, it's really like cyclomatic complexity is the thing you care about there. What do good tests look like? I firmly believe that your testing code can break any conventions you have, like your naming conventions. The method names are probably going to be really long because you're going to say something like, test, this thing does this thing, and then it probably should fail. You should probably leave the like it should probably out, but it should be more deterministic than that. Should be verbose and obvious, and should be easy to change. Like your tests will change, and they should be absolutely transparent as to what is going on. If you don't understand what your test is doing, then like call it a day. Just walk away from it. They need to be painless to maintain, or your developers won't maintain them. So this is a little tiny bicycle in the snow. The TLDR on this is encapsulate as much as possible. Decouple where you can. Be creative about it. Like just do what you have to do to decouple things. When you're in doubt and you can do nothing else, do runtime replacements using aspect mock or anonymous methods, anonymous functions. Sorry. Don't strive for 100% coverage because some of these strategies prohibit that. Work to reduce complexity, measure your crap score, measure your cyclomatic complexity. Just keep an eye on those numbers and make sure they're going in the right direction as you're adding features. Because if they're not going in the right direction, then you're adding risk. So this guy has a long road. Well, he came up a long road, and he's at the top of it now. And it looks like fun. Anyone have any questions? Here are all the resources for the stuff that I talked about. The documentation for PHP Unit, the documentation for Aspect Mock, an Amazon link to effectively dealing with legacy code, Martin Fowler posts, Martin Fowler, and yeah, like these are the things that you want to read when you want to tackle this problem. They're all really helpful. Sort of the closing note on this is actually given away in this right here. Take pride in your legacy code, right? You can make it better than when you opened it. You can hone your craft of being a better developer by working in legacy code in a lot of ways, right? Like, if everything was just greenfields, there wouldn't be any challenges in this job. There's something fun about really improving the quality of code that's been sitting around for years. And if you can do that on the regular and have good skill sets for it, like, you can take pride in that, and you can show up in a new job and be able to kick ass. And that's a skill. I have lots of advice, but it depends on the manager. Is your manager technical, or are they a product manager? All right. So are you looking at your manager when you said that? No. All right. I mean, the thing about it is trying to drive home the safety aspect of it. Explain how fragile the method you have to work inside is, right? Everyone wants to get the features out on time, but nobody is willing to accept bugs, right? And so you have to, as a developer, advocate for the fact that what you're doing is really risky, and that you don't think that it's safe to do unless you add tests. The other aspect of that is, I'm not sure what project management framework you work in or whatever, but like, the complexity of what you're doing increases if your code is fragile, right? In order to reduce that complexity, you have to add tests and refactor that code. That should be accounted for in your story pointing. If you know that adding this feature has to touch this class that is super fragile, and like, as soon as you look at it, it shatters, then you're like, adding the simplest thing in it might be a 5-point story, right? And you have to advocate for that, because no one else has the credentials to do that aside from you. So this was the case at Ovio when I joined. Like, start anywhere. Start on the next feature that you're working on. Right, and that's like a really solid approach, right? As you're going through and you're adding features, as you're touching existing features, just working on ways to refactor that out so that you can improve your code quality, improve your architecture. It's really like, there's no magic bullet to doing it. It's just a start where you can start and start chipping away and be diligent, right? That's why keeping track of the metrics is important, because they keep you honest. They show that you're being diligent. And you can also like use that as a proof point when you go back to management and say like, look, when I started 6 months ago, we had no unit tests. And now we have this much coverage, right? Like, that's a proof point about how effective you can be. And then hopefully, over time, you can also show that your rate of defects has decreased. Cool. So anyone else have any questions? Thank you all.